Hello, in this video I'm going to talk about basic logarithms. Here I have exponential expressions. 2 raised to 3 is equal to 8, 3 raised to 2 is equal to 9, and 4 raised to 2 is equal to 16. And what you will do to convert these exponential expressions into their logarithmic forms is to switch these two numbers. The exponent right here and then the answer here. So if I want to convert this expression to logarithmic form, write log, and then write 2, and then get 8, equate that to 3. And this is read as log base 2 of 8 equals 3. Again, log base 2 of 8 is equal to 3. So what I did is I just switched numbers 3 and 8. For the second one, 3 raised to 2 is equal to 9. Write log, the base is 3, and then switch the numbers. Write 9 first, equals 2. And then last one, so write log, base 4 of 16 is equal to 2. So that's how you convert exponential expressions into their logarithmic forms. Now let's try different scenarios. Solve for x given these items. Start from the left. You're given log base 2 of 4. So you can write the question like this. Log base 2 of 4 is equal to x because you are missing the answer. And then let's convert this into its exponential form. It's 2 raised to x is equal to 4. And we know that if we raise 2 by 2, we will get 4. So the answer here is 2. Now let's try the second one. We are also missing the answer here. So we can write it as log base 2 of 1/4 is equal to x. Convert this into its exponential form. 2 raised to x is equal to 1/4. And we know that if we raise 2 by negative 2, we will be getting 1/4. So the answer here is negative 2. Now let's try the third one where we are missing the base. So let's convert this one into its exponential form. X raised to 4 is equal to 16. So what is the number when you raise it to 4, you will get 16? The answer is 2, right? Because 2 times 2 is 4, times 2 is 8, and then times 2, you will get 16. So the answer is 2. Now let's try the last one where we are missing the one at the center. Let's convert it into its exponential form. 2 raised to 5 is equal to x. So the answer here is 32 because 2 raised to 5 is 32. Now let's try this one, log of 1000. And here you have to note that if you are not given the base is 10. Again, if you are not given the base in the problem, the base is 10. So for this one, it's actually log base 10 of 1000. And then you don't have the answer, so equals x. And then we convert this one into its exponential form. 10 raised to x is equal to 1000. And now the question here is 10 raised to what number gives you 1000? The answer here is 3, right? Because 10 times 10, that's 100. Times 10 again, you get 1000. Now, question is log of 1. So again, if no base is given, your base is 10. Equate this to x because you don't have the answer. So 10 raised to x is equal to 1. Given that equation, what now should be your exponent so that you will get 1 as the answer? So your exponent should be 0, right? Because any number, raise it to 0, you will get 1. So the answer is 0. Now let's try the third one. Let's add some detail. Log base 10 of 0 is equal to x. In exponential form, that's 10 raised to x is equal to 0. And for this one, we have a problem already because we cannot substitute any number to the exponent that will give us 0. So meaning, the x here is undefined. Alright? It's undefined. How about for log negative 1? So let's add in some detail. Log base 10 negative 1 is equal to x. And then 10 raised to x is equal to negative 1. Same with the one earlier. It's impossible to come up with an exponent for 10 that will give you a negative number. So meaning the x here is also undefined. Alright. Now let's have some more scenarios. Log base 2 of 3. So let's complete this one. Log base 2 of 3 is equal to x. Change this into its exponential form. You will get 2 raised to x is equal to 3. Now, if the x here is, let's say 1, you will get 2 as the answer. But if the x there is 2, you will get 4. With that, you will know that the answer here is not a whole number. Now, how do you go about getting the value of x? Set x on the left-hand side first. And then for the right-hand side, first, for the numerator, you will be getting the logarithm of the answer. So, log 3. And then for the denominator, you will get the logarithm of the base. So that's log 2. And again, if the expression does not come with the base is 10. So log base 10 of 3 over log base 10 of 2. And after this, you go to your calculator to get the value of x. The answer is 1.58, 2 decimal places. So that's how you go about this kind of problem. Now let's have the other one. Log base 4 of 5 is equal to x. So the exponential form is 4 raised to x is equal to 5. And same with the last one. If your x here is, for example, 1, you will get 4. If it is 2, you will get 16. So you know that the answer here is not a whole number. So just apply the procedure earlier. Set x on the left-hand side. Get the logarithm of the answer. Set it as your numerator. Get the logarithm of the base, and that will be your denominator. And again, if the expression does not come with the base is 10. And then with this, you can use your calculator to compute the answer. So the answer here is 1.16, 2 decimal places. Let's have 2 more before I end. Now, what if the problem is like this, ln1? ln1 is similar to logarithm, but the base for this one is e. So, ln1 is similar to log base e of 1. And then let's just equate this one to x because we are not given the answer. Let's convert this into its exponential form. E raised to x is equal to 1. And the answer here is 0 because any number raised to 0 will give you 1. And then last, again, if you are given ln, it's similar to logarithm base e. Then you have E4. Then since we are not given the answer, let's equate this one to x. Now let's get the exponential expression. It's e raised to x is equal to e raised to 4. And given that expression, we know right away that the x is 4. And that's it for the basics of logarithm. In the next video, I'm going to talk about naman the properties.